Hello everyone, welcome to my YouTube channel, The Physicist. So in this video we will discuss the basic course that is given to the B.Tech first year students, B.Tech first SAM students, okay, of the branches CSC, ECE, EEE and AIML. The subject is semiconductor physics. Okay, so this subject is taught in the colleges which are affiliated to Kurukshetra University, Kurukshetra. Okay, in the branches CSC, ECE, EEE and artificial intelligence and machine learning. Okay, so this paper of semiconductor physics consists of two exams. One is major exam, okay, which is your written exam. Okay, this is the written exam and it will be of 75 marks. Okay, and one is the minor tests. Okay, this minor test will be of 25 marks. Okay, so this is the classroom test, so it is internal exam. Okay, so this will be taken by your colleges or the university. Okay, and the 75 marks exam will be taken by the university. Okay, so total marks you can score in semiconductor physics is 100. Okay, so the time will be of the major exam will be of 3 hours. Okay, and the purpose of this course is to introduce you to the fundamentals of solid state physics and its applications. Okay, so in this course you will we will discuss a basic solid state physics. Okay, we will discuss the basics of some basic terminologies of crystal structure. Okay, of crystal structure. Okay, we will know about the crystals, what are crystals, what is unit cell, lattice translation vectors, symmetry operation in a crystal, space lattice, what is a basis. Okay, these things are come in the basic terminology of crystal structures. Okay, and we will also introduce you to the elementary quantum mechanics. So elementary quantum mechanics will also be introduced to the students who are studying in these branches. And okay, so elementary quantum mechanics. Okay, this will help in understanding the basics of some basic concepts of solid state physics. Okay, and there will be discussion on the classical free electron theory. Okay, and we'll also discuss the quantum free electron theory. Okay, and we'll also study in this course band theory of solids. What do we mean by bands? Okay, band theory of solids, how they form. Okay, and we will also in the last we will also discuss the basics and some applications of semiconductors. Okay, So that's why the name semiconductor physics. Okay, so we'll discuss the basic solid state physics and basic some elementary quantum mechanics, and using the elementary quantum mechanics we will understand the concepts of solid state physics. Okay, so in solid state physics we also study the classical free electron theory and quantum free electron theory. What is the difference between them? And we'll see the band theory of solids. Band theory of solids is so important for understanding the for understanding the semiconductor physics. Okay, so it is very very important, and to understand the band theory we must understand the quantum theory first. Okay, so this is the basic structure of the course. Okay, so in Kurukshetra University, the course on semiconductor physics is divided into 4 units. Okay, there are 4 units: unit 1, unit 2, unit 3, and then unit 4. Okay, so in unit 1 we will discuss basics of crystal structure. Okay, so basics of crystal structure will be discussed in the first unit. So what is crystalline materials or crystalline solids? Okay, what are amorphous solids? Okay, this will be discussed in this first unit. What is crystal structure, lattice and lattice translation vectors? Okay, what are the symmetry operations? Okay, space lattice, basis, unit cell. What is permittive unit cell? Okay, what are fundamental types of lattices? Okay, fundamental types of lattices. Okay, lattice in 2 dimensions, lattice in 3 dimensions. Okay, we will discuss the special type of lattices called Bravais lattices. Bravais lattices. Okay, and what are the characteristics of unit cell? We will discuss simple cubic unit cells, body centered cubic unit cell, face centered cubic unit cell. We'll also discuss the high hexagonal close packing structure. Okay, we will discuss some simple crystals, some simple crystals. Okay, like sodium chloride crystal. Okay, NaCl crystal, cesium chloride crystal. We'll discuss the structure of diamond. Okay, the crystal structure of diamond will also be discussed, and cubic zinc sulfide. Okay, cubic zinc sulfide structure will be discussed. Okay, and at last of the unit 1 we will discuss the Miller indices. Miller indices, what are the Miller indices? Okay, we will also discuss the bonding types of bondings in solids. Okay, so this is the and also we'll discuss defects, the point defect in crystal, Schottky and Frankel defects. Okay, so we'll discuss defects in the unit 1. Okay, and then in unit 2, okay, in unit 2 we will discuss the quantum theory. Okay, so we will discuss the quantum theory. We will discuss in here that what is the need of quantum mechanics. Okay, what is the origin of quantum mechanics? Okay, we'll discuss the wave particle duality. What is wave particle duality? Things in nature, uh, things like electron and light, they exist also as a wave and also as a particle. So we'll discuss this wave particle duality in unit 2. What is the phase velocity? Okay, what is the group velocity? We'll discuss the concept of wave packet. What is uncertainty principle? Okay, it is very famous principle in quantum mechanics, the uncertainty principle. It is due to Heisenberg and called the Heisenberg uncertainty principle. We'll discuss the Schrodinger equation and its applications. Okay, applications of Schrodinger equations. Okay, it is a wave equation that we use in quantum mechanics. Okay, so in this we will discuss time dependent Schrodinger equation. We'll also discuss the time independent Schrodinger equation. Okay, what is the physical significance of wave function? Okay, so we'll discuss what wave function is and what is its physical significance. So then in unit 3, okay, then in unit 3 we will discuss free electron theory first. Free electron theory. Okay, what is free electron theory? So we'll take a look at classical free electron theory. Okay, classical free electron. Okay, so in this we will discuss the electrical conductivity. Okay, classically how we define the electrical conductivity based upon this classical free electron theory. What is the thermal conductivity in metal? Okay, also the thermal conductivity. Okay, we will discuss the Weiderman-Frenz law. Okay, Weiderman-Frenz law will also be discussed. The successes and drawbacks of the classical free electron theory will be discussed. Then we will discuss the quantum free electron theory. Okay, in this we will discuss the wave function, eigenvalues. We'll discuss the FD statistics, which is Fermi-Dirac statistics. Okay, so Fermi-Dirac distribution function will be discussed in this distribution function. Will be discussed density. What is density of states? Okay, density of states. Fermi energy. What is the concept of Fermi energy? We will see in unit 3 and its importance. What is the importance of the Fermi thermonic emission? Okay, thermonic emission. We will discuss this in unit 3. Okay, then in the second part of the unit 3 we will discuss the band theory of solids. Okay, band theory of solids. So we will make use of basic quantum mechanics that we learned in unit 2 in the unit 3, first in the quantum free electron theory and then in band theory of solids. Okay, we will study the Bloch theorem. Okay, we'll study the Bloch theorem, the Cronin-Penney model. Okay, we will discuss the E versus K diagrams, what they represent. Then we will discuss Brillouin-Jones. Okay, Brillouin-Jones concept of effective mass will be discussed in second part of the unit 3. Okay, effective mass of electron. We will discuss the energy levels and energy bands. Okay, energy levels and energy bands. Okay, What is the distinction between metals, insulators and semiconductors based upon the band theory of solids. Okay, so we'll discuss in this in unit 3, and we will also at last we'll discuss the Hall effect. What is the Hall effect and its applications? Okay, then at last in unit 4 we will discuss semiconductors. Okay, so in the unit from 1 to 3, okay, we just we just made the basic structure, that is we just made the base of the semiconductor so that we can understand a semiconductor in details and in with ease. Okay, so semiconductor, in the last unit, the 4th unit, we will discuss the semiconductors. Okay, so in this we will discuss conduction. What is the mode of conduction in semiconductors? Okay, and we will discuss what is intrinsic semiconductors. Okay, what is extrinsic semiconductors? We will conductivity of the semiconductors, and the charge carriers. Okay, charge carriers. What is carrier concentration in intrinsic semiconductor? What is the charge carrier concentration in intrinsic and extrinsic semiconductors? We will discuss n type semiconductors. Okay, n type semiconductors. We will also discuss the p type semiconductors. Okay, p type semiconductor. We will discuss the charge carrier concentration in extrinsic semiconductors, and then after discussing the basics of semiconductors, we will discuss some semiconductor devices. Okay, so the PN junction diode. Okay, we'll discuss its current and voltage characteristics of a PN junction, and we will discuss the transistor BJT, bipolar junction transistor, and we will also discuss the field effect transistor FET. Okay, we will discuss the metal semiconductor junction. Okay, so we'll discuss metal and semiconductor junction. These are of two type, ohmic and Schottky. We'll discuss in detail what are these. Okay, then at last we will discuss the semiconductor laser. Okay, so this will be the last topic of the